this solution question it's pretty cool. I haven't checked it completely, but it starts off very promising. Yeah. So, you remember the problem?
Yeah.
So you have this is Edwin's solution. Yeah. So, point A equals 0, 0. Yeah.
Yeah.
Okay. B, C. Now the point is to pick the y-axis so that the point's x, y, right? Is it x and y? It's y and x. You have the question sheet.
Yeah. You know, like y and x is like you could define y and x to be lines, not points.
Yeah. Two distinct points on the interior of BC, such that CAX equals CAX equals BAY. Oh, okay. So the crazy thing is they could actually be switched around, yeah. Okay. So these angles are equal, yeah. So so his solution takes advantage of that by making the y-axis, yeah, halfway in between the two angles. Yeah. So that's what, like, I mean, if you just randomly pick an origin and randomly assign points, you're not going to be able to get through it, right? You have to take advantage of something to get through the algebra, yeah. Okay, and so then the gradients were assigned to be minus m, so questionable choice of notation, minus n. So then this would be n and m, yeah? That's the whole point of the choice of the y-axis. And then b was assigned to be minus 1 m, yeah? And c would obviously then kind of be unknown, but it's a scaling triangle. I wonder where that's used in the question. And I guess we don't really need the coordinates of x and y for now, yeah? Does that make sense? Okay. So we need points K and S to be the feet of the perpendiculars.
Yeah, so the extended line.
Yeah, so K is here, right? And then S is somewhere here. So you get a cyclic chord as well. T and L are the feet from AX and AY from C. So here is T, yeah, and L, yeah. Okay, and then KL and ST intersect. Wait, is it KL?
Yeah, it is KL.
Did I do something wrong?
Yeah, this looks shady. Yeah, this looks very shady. I think you placed S in the wrong spot.
Like S here.
Yeah.
Let me just do that again.
You should have points in the correct order.
So it says K, the feet of the perpendicular from B to AX. Okay, so how perpendicular? Maybe it's like that, right?
Yeah.
S is the feet of perpendicular from AY. So maybe like here then, yeah? Yes. T is the feet of the perpendicular from C to AX. C to AX. So that's T, right?
Oh, I get it. Why? It's because you drew the angles, right? They're actually very, very different. That's why they don't seem to intersect the lines.
Okay.
It's because of the angles you drew.
Alright, and then ST. So S is the T, and the L is the theta perpendicular from C to AY. L is somewhere here, I guess. So then the point ST and KL are meant to intersect on BC. Okay, yeah, maybe if S was actually just like over here, right? Then ST, and then KL would have to be down here. Okay, so that's kind of the idea, yeah? Yeah. Alright, so did you guys find the coordinates of
95 coordinates for x and y.
Huh?
It's somewhat easy to find the coordinates of x and y than others.
You need to find the coordinates of x and y. X is just like any point on the thing. You don't need to have the x as a line, actually.
Yeah, like you can actually define coordinates for x and y.
Yeah, exactly.
So the point is, so look at AY, right? What are you doing?
Yeah.
Huh?
Nothing.
He's searching on math.
Get rid of the phone.
He was searching on like some math things that he didn't really understand.
Alright, so this is got gradient minus n, right? Yeah?
Yeah.
So look at the equation of this line is y equals minus nx, isn't it?
Yeah.
Right?
Yeah.
The equation of so the equation of the perpendicular line is got. I mean, you don't know the slope is 1 on n, right? Yeah. So for example, like which point do you want to find first? You want to find S?
It doesn't matter.
Yeah. So if you want to find S, right? The slope of the line BS, right? Yeah. The equation of the line BS, right? It goes through minus 1m, yeah? Didn't you learn this in school?
Yeah.
Why can't you apply it?
Oh, so it's like y minus m over x plus 1 is equal to the slope of bs.
Yeah, so we don't do over, we do.
Oh yeah, you know that's actually slightly more. That's actually more convenient, to be honest.
Because if you do over, you lose x equals minus 1, right? So that wouldn't be the full line, it would just be like 2 rays.
Myth. Doesn't matter.
Alright, sometimes some things was going to matter. When it does matter, it's not going to work either, by the way.
Wait. Oh yeah, because BS is perpendicular to.
Yeah? So basically, you're like at school, you're just learning stuff that you don't understand. Okay, so yeah, does that make sense? And so if you want to find what S is, right? You want to find the intersection of this with y equals minus nx, right? So what do you get? You get minus nx minus m equals 1 on n times x plus 1, right?
Yeah.
So then minus n squared x minus nm equals x plus 1, right? So then x is equal to, you know what I'm talking about, right?
Yeah.
Oh, oops, it's not quite finished. So you put the x on that side. That's minus nm minus 1, right? It's x outside of n squared plus 1.
Oh, well, yeah, that works. Because n squared plus 1 will always be positive. 1 Unless if you say suppose n is equal to I.
And then y equals
Crap. Minus
sub into here.
I know. N
What?
squared n. N squared n plus 1. N squared n plus n over n squared plus 1.
Yeah, so just times this by n, right? Minus n.
This is n squared m
The plus is
oh,
n
plus
squared m plus n on n squared plus 1. Yeah? Does that make sense?
Yeah.
Yeah, so okay, so can you see now? Okay, so what do we have now? We have the point S, right? S. So S is equal to minus nm minus 1 on n squared plus 1, right? Comma minus n outside of nm plus 1 on n squared plus 1. Yeah? You see that? Yeah?
Isn't it plus n?
It's a plus, yeah. So
Fine.
okay.
Fine. Doesn't matter.
So can you see how to get the other points now?
Yeah.
So what do? We got S was minus n with B, yeah? Does that make sense? Yeah. So if you want to get what's this point here? K?
Yeah.
Yeah, so if you want K, right? Yeah. You just replace n by minus n.
Yeah.
Yes? So you don't have to go through the whole process again, yeah? You can just do n m.
Still minus 1, right?
Yeah, it's still minus 1. So does this work? Let's see. Minus n outside of does it work or not? So I guess it's n squared m still minus 1. Yeah, I mean this once you know that, this is obvious now, right? It's just n times that. So you don't have a choice for the y value. But it's good to know that it's still gotten by. Is that what he got as well? Yeah, that's what he got as well. Yeah? Does that make sense? Huh?
Oh, because that's just on n, so just place a minus.
Yeah. Does that make sense? Okay, so actually, it probably would have been better to do the C first, yeah?
Wait, let me see. I have a feeling it's like over n squared minus 1. I can't be sure.
N squared minus 1.
I don't know.
Oh, why?
Wait, should we? Just in case, should we just do it for K? Because, like, there could be like an error or stuff.
Oh no, he did it the whole thing with K, so that's what he got as well.
Okay.
You wanna see it?
And then, yeah, I get it. I trust his judgment.
Yeah, but not mine.
I don't know. I didn't know it was his solution, but okay.
Yeah, I mean, I'm adding some things to it, but it's essentially his solution. Yeah. Okay, so actually, it would have been easier if I did this first, right? You know why, right? Because if I did C and CM first, right, I could just sub in um, -1 for C and -m for M, and I'd get these results too.
Yeah.
So I could just do one calculation and get all 4 results. Yeah, that's pretty cool. So that's something, I guess it's more of an innovation. So I mean, let's just do it again, okay? Just so you feel better. Wait, you don't need that chair anymore, do you?
Yeah, just leaving it there.
Okay. So how would you find let's say let's find L, right? Yeah. So CL is perpendicular to AY, yeah? So CL perpendicular to AY. So and the crazy thing is this is like a really hard, like it seems at face value to be a really hard geometry problem, right?
But it's just Coord Bash.
But once you pick the nice axes, the problem that's kind of like it's not it's not that much of a bash really. Like if it was, it'd be hard for people to even get through it. You know what I mean? Okay, so CL is perpendicular to AY. So the equation of AY.
Epic.
Huh?
Yeah, okay, got it.
So can you see, like, the point is you should be convinced that you know how to get to the answer now, even though you don't know the answer is true, right? It's like a routine.
Yeah.
You find the points. That's what coordinate geometry is, right? You find the points, find the point of intersection,
And just prove it lies on the equation of
and then find, yeah, exactly.
Yeah. Okay, got it.
And like you don't know why it happens, but it either will happen or it won't, right? Okay, so the equation of AY is, well, the equation of AY is obvious, right? The equation of CL is y minus CM equals x minus C, right? And the slope is, well, the slope is perpendicular to this, right? So it's 1 on n. Does that make sense? Yeah. So you get, what do you get? And you want to sub in y equals minus nx, right? So you get minus nx minus cm equals 1 on n x minus c. I really don't need to do this for you, do I? Minus n squared x minus cnm equals x minus c. So then x, bring the c over, right? C is 1 minus nm equals x outside of n squared plus 1. Yeah? All good? So what are we solving for here? X, right? X equals c outside of 1 minus nm on n squared plus 1, right? Yeah? So now we have our coordinates for L, right? L. C 1 minus nm. So notice here you got like you have one choice of, so you got the choice of axes and you also got one choice of scale, right? That's where the minus 1 comes from. Does that make sense? You scale it so that that's minus 1. Alright, anyway. N squared plus 1. Okay. Yeah. Do you appreciate it as much as he does?
The Coord Bash?
Yeah.
No, it's a very ugly method. There has to be a better method instead.
Well,
I mean, it works, but just.
this is not ugly, by the way.
It's so good.
I mean, it's not too ugly, but it's just like not the best method either. There could be a better method. I can't be sure.
Like, it's not ugly because you have to make a choice. That's the point. So once you make the starting choice, the rest is routine. Yeah. So it changes the kind of problem. It kind of puts the problem all at the beginning. And it doesn't explain why something's true. It just tells you that it is. Okay, what's the y value?
Minus nx minus nc times. Well, just nc times n and minus 1. Wow.
Yeah. So it's 1 minus nm. Is that what we got as well? L. Where's the equation for that? He did t next, I guess. But L is minus c times O. Yeah, 1 minus nm. Yeah, so it's the same, but he had the minus sign on the outside. Yeah, so I guess he had the minus sign on the outside. So nm minus 1. Yeah, it's the same, right? And then times by minus n will give you nc. Yeah? Okay, t. So can you see you don't have to do it again for t, right? Yeah? So for t, you would just replace minus n by n, right? Yeah? So that would become a minus n. So they'd be both positives, I guess, yeah. So this would be c nm plus 1, right? 1n squared plus 1. And then you can check it twice now. You can just put it in, or you can sub it into the equation, right? Times by n. Yeah? But once you put that in, it shouldn't change the first term, and the second term becomes a plus as well. Okay, so it's n c nm plus 1. Yeah? You agree? And I think that's what he got as well. So the t, yeah, c outside of 1 plus mn. Yep, that's what he got for t as well. Okay, so we just saved going through that process again. Yeah, and actually, if you did this first, right, you could sub in c equals minus 1, right? Yeah, does that make sense? So if you subbed in c equals minus 1, yeah, and m equals minus m, right? Yeah, you should get back this. Do you agree? So if you subbed in c equals minus 1, so that's 1, right? And then m equals minus m. So you get minus nm minus 1. That's what you got here, right? And the n's doesn't change, yeah? That's pretty neat, isn't it? So if you wanted to be really economical, okay, you would just do that calculation only, right? And then m to minus m, n to minus n, m to minus m, c to minus 1, m to minus m, c to minus 1, n to minus n, yeah? Yeah. So actually you could do that in 1 minute, okay? Just be economical. Okay, so what do we get for L? L is minus C and M minus 1. Yeah, that's what he got as well. So. Okay. So how do we proceed from here?
We find the equation of lines and then we find the equation of BC. And we prove that they're somehow concurrent.
Yeah.
Wow. Best method ever. Ha ha.
Alright, so let's find the equation of KL then, yeah? Did you notice something was parallel before?
Yeah, that's useless. Forget it.
It's two pairs.
Yeah, but that's useless.
Oh, you mean like BK is parallel to... Yeah.
That's useless.
Okay, so let's see. Should we do this together? I guess you could technically do it yourself too. So, okay, so how would you find the equation of KL, yeah?
Oh yes, you do the weird thing. So like y minus y1 over x minus x1
Yeah.
is equal to y2 minus y. Yeah.
So I've always found that equation a little bit weird because it's not symmetric, you know, like you find the gradient first and then you pick a point, you know what I mean?
Yeah.
I think it's much more natural to find the equation like, kind of like this would be the equation, it'd be x minus xk, right? Yeah. Times y minus yk equals x minus xl times y minus yl. Yeah.
Wait, what?
So can you see if when you expand this, the xy cancels with the xy, yeah?
Yeah.
So that makes this a linear equation. Yeah? And it's linear equation satisfied by 2 points. So it has to be that, a linear equation, right?
Oh yes, I get it. Yeah.
Okay. So that's the equation of KL, and it's also the equation of ST.
A, B, C. Yep.
ST. There might be some cool symmetry that will let you see that it intersected straight away on BC. Actually, the thing is, once you found the point of intersection, right, you wouldn't need to, I guess, yeah, it would look weird. Like what would make sense is like you find the point of intersection, right, and then you sub it into the other equation, yeah. But what would not make sense, but would work logically, is if you just knew the point of intersection from all the working, right, and then subbed into all three equations. Does that make sense?
That's pretty dumb if you ask me.
Why?
Because like if you sub into 3 equations, that's a lot of messy algebra. Whereas if you find the intersection of 2 of those lines and sub it into the third one, it's not as messy.
It's not necessarily true. I don't know. You were here actually when we did that. We found that, remember, we had 3 equations. It was the first practice problem complex batch. We had 3 equations and we just simultaneously found the point that was in all of them.
So which question was that?
What was it? It was practice problem 1. Like it was like ABCD is a cyclic quad, and then it was all the orthocenters, the lines from the orthocenters.
Oh yeah, we did that. You said that.
Yeah, so you have to like understand. You have to react to the experiences you have, right? Directly contradicts what you said. Okay. Well, let's find this equation, yeah?
Wait, is that a formula? X minus x k times y minus y k.
Yeah, that's the formula for a straight line.
I have literally never seen this formula.
I just explained it to you.
I mean, I know, but I haven't seen it before.
Yeah, I know. It's shocking, but like, that's what it is.
Looks like point. Never mind. I thought it's point gradient.
It's the same thing. Look at like if you put. So basically, if you put like.
The quarters of x k and y k. You get both sides are equal to 0.
Maybe it should be no. It should be x minus. Wait, is it x?
Is that a weird thing?
Should this be L?
Yeah, I have a weird thing in this equation as well.
Yeah, it should be. This should be L, right?
Yeah, it has to be L.
And that should be K. Yeah.
Yeah.
Yeah. See, the point is, if you divide this by that, right? Yeah. And you divide that by that, right?
You get two gradients.
They're not really, but yeah.
You get that point gradient form thing, right?
Yeah. Wait. y1 minus y2. No, y1 minus y2 of x1 minus x2.
Yeah, it is.
Is the gradient form.
So this was the equation of that line, right?
Wait, isn't it just
But the reason like you would look for something like this is because you're given 2 points, right? And you're asked to find the equation of a line. Why would you first find the gradient and then choose one of the points, right? That doesn't make sense. You understand what I'm saying?
When you're given 2 points and you're trying to find the equation, you find the gradient and then get 1 point and then
Yeah.
some bracket.
So that choice is unnatural. You see what I'm saying? The equation formula for that situation should have no choice required for the points, right? It should take into both points and get you an equation. And this is a nice way of doing it, right? Okay, now that we got the equation right, I'm going to try some things. So x minus nm minus 1. See, maybe we should learn from experience. So if I'm finding KL and ST, right? What's the relationship between KL and ST?
Well, you mean x minus nm plus 1, right?
Huh?
Because you did x minus xk. It should be x minus nm plus 1.
Oh yeah, well I mean it's inside the brackets.
Haha. Very nice invisible brackets.
Oh, it's a fraction. The fraction is already brackets. But can you see that the relationship is the equation of KL, right? Can be converted into the equation of ST. Yes? You see that? How do you do it? Well,
You change some of the.
you change n to minus n, right?
Yeah.
Okay, let's just find this equation because we're starting to talk too much. Y plus C. Are you following, Leo?
Yeah.
You're doing this, right?
I'm doing algebra.
You should do this. Because I've chosen these things because I think these are good for you. If you disagree, that's fine, but you have to also be right. And most of the time, you both are wrong. Okay? See, me making you do exams here is a scam. I agree with you. Yes, but only if you're able to do it at home. Yes.
Yeah.
And have you ever done it at home?
Only once.
Basically, never. Yes.
Yeah.
So therefore, it's not a scam. That's the point. Okay.
Cool.
And I hate doing that too. Okay. All right. So plus this is x minus. So I didn't do the right thing here. I need an n, right? I need a minus n. Right? Yeah? I put in the x value, not the y value. So that should be this.
Yeah.
Yes? The x one should be that. X plus c n m minus 1 on n squared plus 1. Y minus n minus 1 on n squared plus 1.
Now you destroy the n squared plus 1.
Oh yeah. You certainly could, yes?
Yeah. Actually, doing it will make the equation even worse. Actually, no, it's not. Both. Oh, crap.
Yeah, I think that's a good way to do it as well. Yeah.
Oh, no.
Okay, the x and y's cancel, yeah? I mean, it depends what you're looking for. Like, sometimes this is the equation, you know what I mean? But if you want to put it like in y equals mx plus b form, you could.
So this is algebra. Yay. Imagine using Coord Bash and getting an equation like this. Best idea ever.
It guarantees that you get the answer, so that's good.
I mean, at least it helps you get the answer. I guess that's good, right?
It guarantees it, basically.
Guarantees? Yeah. I wouldn't use that word.
Yeah, I mean, if you put it in a computer, it would tell you the answer, right?
Yeah.
That's what he means.
But we don't have a computer. It's a test.
Yeah. But why can't you do some simple algebra? This is like towards the end of the problem now.
And like it just gives you this equation, which is basically a big F U to the face.
Wait, what does that say? N plus.
The last one?
Yeah.
It's nm plus 1. It's just n times the x coordinate.
N plus. I'm scared I actually ruined it because then I would have messed up the whole calculation.
Okay, so the x, y's cancel. And you get this product. Plus this product. Plus that product. Yeah. So let's do the constant term, yeah? So you get n m minus 1 squared, yes, times nc on n plus 1 squared plus plus the same thing, isn't it? You get 2 lots of this. That's the constant term on the left hand side. So times this and then plus this. Yeah. And then for the coefficient of x, you get this minus this, right? So you get n squared plus 1 minus c, basically, right? That's that 1 minus c. Yeah. Yeah. And then plus y. So y is this thing now. So it's that times y minus this, yeah? C minus 1. Minus. It should be a negative now, yeah? So you can maybe write it as negative nm minus 1 n squared plus 1 that's 1 minus c, yeah? Oh, that looks very similar, doesn't it? Yeah. Equals 0, yeah? That's the equation.
I don't.
Huh?
Wait, for 2 times nm minus 1 squared times nc over n squared, n plus 1 squared, shouldn't the denominator be n squared plus 1, not n plus 1 squared?
No, it's n squared plus 1 squared, you're right. Yeah.
Oh, yeah.
Does our equation not match his? So the coefficient of x divided by, oh, okay, because there's a whole, I guess we can times everything by n squared plus 1, yeah? So that's something we can do. Get rid of that, get rid of that, get rid of that, yeah? And so then we see the slope should be that divided by the negative of that, yeah? Which is n. That doesn't seem right. Something went wrong here. So this, the coefficient of y, right, is this number here minus this number here, right? So this should be plus c. Yes? Okay, now we're good. Because now the slope is n times 1 minus c on 1 plus c, yeah? Yeah. Okay, so what would that equation be? And I guess you could also divide it by nm minus 1, yeah? So we know that, how do we know nm is not equal to 1? nm be equal to 1?
N equal to 1.
What would it mean if n times m was equal to 1?
This means that it is possible. Is it possible? Yeah. It is in fact very, very possible.
Really?
Yeah, if you have like m be like a gradient, m be greater than 0, that's m be greater than -1, that's than 0, and like n be less than -1, then it's actually quite possible.
Hmm.
But it doesn't matter, does it?
I guess I was going to cancel this out, but they can wait. Sure. So you see what our equation is now? It's basically this. Yeah.
I found 2 equations. One more and I'm done.
Yeah. Okay, so if you get rid of nm minus 1, okay, you get rid of this square, get rid of this nm minus 1, and you get rid of this nm minus 1, yeah? So then your equation simplifies quite a lot, actually. And if you want, you can times it by n squared minus 1 if you want. N squared plus 1, but we don't have to. So what do you get? So you get 0 equals, oh, you can put the y on the other side if you really want. So y outside of 1 plus c. Yeah. So can you see like c might not be minus 1 just because it's like scaling? If c was minus 1, it'd be like, actually no.
Yeah, c cannot be equal to -1.
Yeah. Anyway, so let's have a look. X times n 1 minus c plus this, right? 2nm minus 1 times nc. 2nm minus 1 2nc n minus 1, yeah?
Still not good enough. Let's expand the whole equation. Just expand it. It doesn't matter, does it?
If you expand it, it's actual hell.
I don't care if it's hell. At least if it gets the job done, then it's good enough.
This is contradicting what you said earlier.
I don't care. Just get the job done. Yeah.
No, we're not about just getting the job done because the job, you don't even know what the job is.
Yeah, true.
We don't.
Well, I just realized there could be infinitely many solutions to x and y. It's crap. You know, I think it's good enough. Just leave it like this for now.
Yeah. Yeah, leave it like that for now, yeah? Okay. Can you see what the other equation is, even without doing it? So whatever form you want it in, you can get the other one straight away, can't you?
I'm so close to finishing.
So can you see, because you can get from K and L to S and T by doing n to minus n, right?
Yep.
You
You
should be
just
able to get,
replace it here.
you can get the equation to,
Yep. Just
that could save a page, well, 2 lines.
2 lines. Incredible.
So here, 2nc nm plus 1, right? On n squared plus 1. Minus n 1 minus cx
Oh, you just add both sides.
equals
Okay.
y1 plus c. Oh.
Now you add both. Now you add both the equations.
Yeah.
Epic. Epic. Gets the job done.
Gets the job done.
Are we done?
Not yet.
Well, pretty much.
But like,
done the
if you
first
do,
part.
so I'm saying like this way of doing it just makes it simpler, right? I mean, the original idea wasn't mine; it was the coordinate geometry of Edwin, right? Which is good, fantastic idea. I'm just trying to make it more efficient.
Because Edwin is big brain, so he figured it out.
Yeah.
I wish I
And,
had big brain.
and this further validates my approach of not doing the problem, because if I'd done it, I would just be maybe I would find another solution. But the point is, like, it saved me the trouble of doing it, and he did it just as well, you know. And I can spend my time doing the problems that people started but didn't finish, you know.
Edwin is big brain.
Yeah. So. Let's have a look. So then we got the gradient of ST is basically the same, right? But minus, hold on. Something didn't work out.
Nah, everything's fine.
Oh, it's C minus 1, yeah. So C minus 1 and C minus 1, C plus 1, yeah? The gradients match. And then I'm pretty sure the equation has to be right as well. Yeah, so it's kind of crazy, right? Now you can find the equation of the intersection pretty easily.
Yeah.
So I think even if you get the question right, it's still good to review your solution, you know what I mean?
Yeah.
Because you can improve it. Have you ever heard Gary Kasparov talk about chess? You know who Gary Kasparov is?
Imagine playing chess.
Yeah. You know who he is?
Isn't he like a Russian chess guy?
World champion. Like, he was one of
wow.
like the longest world champions ever. And he was like world champion across generations.
Didn't it like?
So he was the one who played the
It's in
computer.
Magnus Carl right now.
Yeah. But Magnus Carlsen is so young that he couldn't possibly accomplish what Kasparov accomplished.
Didn't he have? Didn't that guy have a really high IQ?
Yeah, apparently. I don't know the details. But he can remember like all the games and stuff, and he can play without looking at the board.
That's like all grandmasters after they
Yeah.
Yeah.
I guess like it's like the grandmaster skill is there, and only the really good ones get to exhibit it. So like you think that he's even more special.
Like playing like
But some of those are easy for lots of grandmasters.
Yeah, playing blindfolded chess is hard, but like playing it against 3 people,
Yeah.
at once, and they're all professors, and he beat them all.
Yeah.
It's like ridiculous.
I mean, chess is really balanced. That's why it's good.
I can play blindfold.
It's really balanced. That's why.
It's pretty good.
Blindfolded chess against
There's no OP strategy in chess. That's why it's so good.
blindfolded chess against 2 people is like impossible.
There's no OP strategy in chess. Making
Yeah,
chess
the
one of
way
the
like
most
this, it makes it
balanced
so easy to eliminate variables, right? If you have a nice equation. Yeah? Look at this. This is basically the nicest thing you could have.
things. Look at this beautiful equation.
I swear if you just found the equation of BC, you could probably just eyeball an intersection point now.
Okay, I finished the question.
Just like what we did
I
before.
found all the equations. Now it's time to just sub it in.
What would be like an eyeball intersection point? What is the equation of BC?
BC, you just do like what you just do with other equations.
Yeah, exactly, right?
Yeah, exactly.
But I can't just sub in some numbers. So it'd be like, maybe I can find it at the end. More in the spirit of what's going on here. Okay, so you want to add them or you want to subtract them? I think
Subtract.
adding them looks pretty natural.
Subtract.
Adding,
What?
Subtract.
Why?
Either way works.
But adding is so
Right.
much more natural.
adding,
Yeah, but subtracting also kind of works.
you learn adding before subtract.
Yeah, subtracting might not even exist.
But
Subtracting
you just
might not
adding a negative number.
Yeah.
Nah, bro. I learned multiplication before I learned addition. What am I joking?
Okay, so then you get 4nc, right?
Happens if I learn how to sketch y is equal to
So 4n squared mc.
Imagine learning trigonometry before learning addition.
2y 1 plus c. So
Now
that's
you
like the
just-
simplest thing ever.
Yeah, that's not simple.
What?
It's pretty bad. It's like the denominator is pretty weird if you ask me.
It's so simple, you don't even have to sub it back in. You could just do the other subtraction.
Oh,
now.
finally know why it's scaling because like if c is equal to -1, it doesn't work.
Okay, I found all three equations.
Holy, bro,
Oh, does that match?
I don't know.
bro.
If it
Bro.
doesn't, I'm gonna be big sad.
No, you won't be big sad.
It took so much work to make.
It's obviously
And I'm probably
got.
gonna simplify it properly.
I think do you have the gradients backwards? Do you have x and y backwards?
Huh?
You have x and y backwards, I think. Like, for example, can you see the gradient is n times 1 minus c on 1 plus c, right? That's like the opposite of this one. So I think you have x and y swapped for some reason.
Wait, the gradient's just x1 minus x2, y1 minus y2.
No, it's y on, it's rise over run.
Oh, crap.
Oh shit.
How could I mix that up? That means I messed up all the gradient.
Stop doing like year 11 high school crap.
Wait, what did you do? Let me see.
No,
Bro,
I
bro,
thought the gradient was x1 minus the x2 minus x1.
bro.
Frick,
bro,
that means I got the
bro,
everything
bro.
else wrong because when I started back in,
See, like school maths, it's
Bro.
like your attitude for Olympiad maths. It's like, but the
I-
questions are so trivial, you absolutely gain nothing from it.
Exactly. I
It's
didn't
like-
do it.
what I
Like,
gained,
let's just get the job done, and then the job is like, what's x? And it's like, x is 5, and it's like, no, they told you x was 5, so you just had to write x equals 5, and then you got the job done and it's done,
Exactly.
and
you
then,
probably
like-
got 5
and you
points
feel
for that.
good, but you don't realize you've wasted your life there. You understand?
doesn't matter. I just did some algebra. It's good for my brain.
It's like, say x equals 5, and you're
At
like,
least I
x
got it
equals
right.
5.
Right?
At least you got it right. How do you know it's right? The person doesn't know it's right. He just knows what the answers are at the back.
Now I'll never forget the gradient formula ever again because of this moment.
Yeah, sure. What's the gradient formula?
Okay, so instead of procrastinating, maybe we can do the subtraction now. So if you do the
No.
subtraction, right? Which one do you want to subtract? Maybe we can subtract. So this is 1 plus 2.
theta is equal to absolute value of
Maybe we
n1,
could do 2
m1
minus 1.
m2 over 1 minus n1
2 minus 1,
Let's do
yeah?
that.
And then you get equal, and put it on the other side.
n2.
So
Plus. How do I get power formula?
2 and 1 minus c times x equals this minus that. Yeah, so now you just add the second term.
See, it's not too bad. Still pretty good if you ask me.
This bash.
I mean, like subtracting.
Yeah, you're right. Because I mean, it's a natural way to get it's basically the symmetry between x and y is adding and subtracting, right? So if you do want to get y, then you should maybe subtract to get x as opposed to sub it in, right? I don't know. So let's see. You have what is this? What am I doing again? So it's 2nc times 2, right? 4nc. That's x and that's y. Yeah. And then you just have to show it lies on BC.
Exactly. That's actually not too bad. That's
No,
actually not
this-
You're almost there, right?
This requires no thinking whatsoever. It's just algebra.
Yeah, but all the thinking is at the beginning. That's the point, right?
Like you
So-
have to, if you set. If
So
you
basically, this is going to be the theme for the day. Okay, it's like you take the problem that you know nothing about, right?
Yeah.
You struggle endlessly, right? You transport it into a situation where you know everything about, right?
Yeah.
And that's basically the solution, right?
Except the solution is very tedious.
Yeah, but you don't. Is it? All I did was talk. If I just wrote, I would take like 5 seconds.
But like you,
see,
Yeah,
I was
no
faster
worries.
micro-computing all three of them.
and then you actually screwed up.
And I actually screwed up. So it doesn't count.
No, no. You're actually faster than me. Okay, mentally. Let's be clear. Okay, you're faster than me mentally. You're faster than me mentally. Okay,
Actually,
you just have to go in the right direction. Okay, I
Oh.
promise you. I have been getting slower since I've gotten back into Australia as well. But like,
where were you?
mentally, you guys are quick. Okay. All right. So
Yeah, we're
how do you
short.
find the equation of this line again? So it was x.
Use your formula.
Alright,
X plus 1. X plus 1
x plus 1.
times y minus cm.
Y minus cm. See, this is the first time I've actually really used this in action because I never used it at school and I just came up with it because I thought it was natural to have a formula like that. So y minus
Is
cm
equal to x minus m. Is equal to
is equal to
x minus m. Y minus c.
y minus c,
Oh crap. Y minus.
y minus m, yeah?
Oh shit.
X minus c.
Shit, I screwed up.
Yeah?
Shit, I screwed up.
That's fine.
Shit,
That works
shit.
out, right?
And then you expand it, and then you simplify. Collect. Cancel terms out. And yeah. Accumulation,
Yeah,
cancellation.
so the xy cancels out. What's the constant term? You get minus cm on one side and you get minus cm on the other side. What? Really?
Yeah.
Plus cm on the other side. So you get 2 cm, yeah? And then let's work on the right hand side then.
Doing this mentally, haha.
And then what's the coordinate of y? Y, you get y times minus c, yeah? And here you get y times 1. So it's minus c minus 1 times y. Or you could say minus c plus 1 times y, yeah? This is equal to, make it equal to 0. Okay. We should say something like that.
What about the x?
And then the x is minus cm, you can put plus cm. And here's plus cm minus m, yeah? So m is cm minus m, like this, x. Yeah?
And then you sub it.
Yeah. See, look, we didn't even have to rearrange the solve for y, right? Because it comes like that. Yeah.
Wow. That's epic.
Isn't it?
That's totally epic.
That's cool, isn't it?
Haha.
Okay, and we didn't even do the 1 plus x thing because it comes like that, yeah?
Very epic.
Yeah. That's amazing, actually.
Amazing. Yeah.
Minus m plus cm. So we can do this, the coolest substitution straight away. We can first though, we can make this 4, I guess, if we want, but yeah, so we can do it. Let's just erase some other stuff. Are you with us, Leo?
Yeah.
So if you times it everything by 2, right? You get 4 cm. Okay. And it's supposed to equal 0. That's the equation, yeah? Okay, and then the y becomes minus that, yeah? Minus 4n squared c cm on n squared plus 1, yeah? Okay. And the x becomes, oh, it's the negative of that, yeah? So it's 2 times the negative, so it's negative 2m times that. Oh, no. Okay, you have to divide this by 2n. Okay, no. We times it by 2, so you have 2, so it's negative m out the front. Yeah. I don't know why I'm explaining it. Should I just write down what the answer is? Yeah, so it's negative.
Should I redo all of this? Let's see how long it takes.
4nc. It's 4nc on n squared plus 1, right? Divided by n. And it's a negative. Is that right?
And therefore you could.
Well,
Well,
do this all again.
How did it become 4 cm?
there's like an m that's missing. Oh yeah, I should put the m here. That's this m. I forgot to put that in.
Why is it 4 cm? I thought it was 2 cm.
I times everything by 2 so I could sub these
wow.
in.
Wow. So you get everything and then you cancel both and then you divide by 4 cm. Right?
Yeah.
And then you get some really weird equation. And then you do something weird.
Yeah, we can do a lot of things now because we're on the home stretch. It's almost like, see, look, we can cancel out the 4 cm's, for example, yeah?
Yeah. And then you cancel out the n from the first fraction. You get minus 1 minus n
Yeah.
squared over n squared plus 1 is equal to 0. Which is obviously true.
Huh? Is it obviously true, did you say?
Yep.
Minus 1 on n squared plus 1.
Minus n squared.
So minus n squared on n squared plus 1. Right?
That's obviously true.
Oh, that's awesome.
That's so awesome. Definitely didn't have to go through all of this to get to this result.
Just saying, I'm
Go
reading.
through all of what?
Algebra.
What algebra?
Look at this. We did so much algebra. It's not even funny.
Yeah.
No
But that's
wonder why
kind
it's
of
5
cool.
pages.
Yeah, but we saved a lot of work too, right? Okay. Okay, that's really awesome.
Epic Coord Bash.
Yeah, so I didn't quite get to read. Yeah, that works out quite nicely, huh? Yeah, I guess this is maybe like a study in using the general form of a linear equation, yeah?
Epic solution.
I'm redoing all the algebra again.
No, but you solve the question. Well, you don't have to do it.
Yeah, but I'm doing it as punishment for myself.
Why would you punish yourself?
For mixing up the gradient formula. Like, how could I?
You know what? You know that Michael was trolling you, right? The gradient formula was totally correct.
No, it's rise and run.
He went wrong, run over rise.
I was trying to troll him.
No.
You should have just said, yeah, I was trolling you the whole time. But never mind, you didn't. So you're doing this all over again.
Yeah, it's probably because I play games like 11 hours per day, every day.
Actually,
Yeah.
yeah. How like you